Okay, now we would like to give a proof of this equation here. If, without looking too hard, it's not too hard to see this is like a quantified version of this rule here, right? Because we've got for all x, p of x implies q of x, and not q of z, therefore not p of z. So it's similar to this rule here. There should be a similar proof to proving this, but with extra steps with quantifiers. So as per usual, we write the goal down the bottom. For all z, for all x, p of x implies q of x, and not q of z implies not p of z. Okay. If we want to prove something with a quantifier, a for all quantifier at the front, we have to try and prove it for an arbitrary a. So we're going to replace all the z's with this arbitrary a. So we want to prove for all x, p of x implies q of x, and not q of a implies not p of a. Okay? How do we prove this statement? Well, this is an implication, so we assume the left and derive the right. So we assume the left side. For all x, p of x implies q of x, and we assume, so this and not q of a. We assume this, try and derive that. Okay? We have this equation here, so that means we can use AND elimination to break it up into two parts. For all x, p of x implies q of x, and not q of a. Alright? If it's true to say for every x, p of x implies q of x, then certainly it's true for a. So therefore p of a implies q of a by OR elimination. Okay, so we have this, we now have to try and get not p of a. If I'm trying to prove something with a negation, the only thing I can really do is assume it's the opposite and try and drive a contradiction. So I'll assume p of a and try to get false. We have p of a, we have p of a implies q of a, therefore q of a, and then these two terms contradict each other, therefore false. Proof is done, so we put in our line numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That was an assumption. That was AND elimination line 1, and so was this. This was for all elimination line 2. This was an assumption. We have p of a. We have p of a implies q of a, therefore q of a by implication elimination lines 5, lines 4. These two terms contradict each other, so we have false by not elimination lines 6 and 3. So usually you cite the p first, and actually let's check our rule sheet on the back to make sure. Where's my rule sheet? Here it is. So not elimination, p, not p. So the first term here should refer to the p, and the second term here should refer to the not p, or q of a in this case. Assumed p, derived false. Assume p of a, derived false, therefore not p of a by negation introduction lines 5 through 7. This is an implication introduction. Assume this, derive that. So implication introduction lines 1 through 8. And this is for all introduction line 9.